Okay, so for today's session, the original plan is we want to discuss two materials. First is how we could implement the mathematical models uh, to be solved using exact algorithms such as implemented in mathematical programming using a software called AMPL. It's a commercial software, but somehow they provide academic version of the software without losing the full commercial capability. So I guess that the limitation is that it can only be used for research and academics purpose. So the link that I sent you earlier in the groups, it consists of a file that you can download and you can use for academic purpose, such as for your research and for your thesis, perhaps, but not for commercial use. And well, originally we will discuss this and then move on to another techniques in which we call multi-criteria decision-making techniques, where those techniques were considering uh, more complex decision-making than just the mathematical programming approach that we studied earlier. That approach can take account the subjectivity of the decision maker in the decisions. But I thought that while I'm creating this slide, I think that it is better that I teach because these two topics is discussing about practical applications. So I think you will need some practice before move on from one tools to another tools. So that I decide for this week, I may want to deliver you the first part, and we will discuss the second part at the next week's session. Okay, let's start from the contents. Well, it's focused on how the mathematical programmings will be implemented on a solver or optimization tools. Well, basically there is a lot of optimization tools and software that you can use. For example, the one that we already tried earlier last 2 weeks ago, such as the Excel solver, yeah, and another very popular solver also available, such as Cplex and Lingo. That those kind of software perhaps you might already heard about if you studied industrial engineering for your undergraduate degree. But for this one, we will focus on AMPL software. And I think that AMPL is not a software, it's an optimization tools that uh, it can call many different software as necessary. Such as, for example, you can use the AMPL tools to call Cplex solver, AMPL tools to call Gurobi solver. Later on, I will explain more detail about it. And at the end of the session today, you will have a chance to exercise what we learned in the class. And of course, we will implement it on the location decision models that we already studied in the previous week. For the course outcome, we will cover two course outcome in which today, even though that you will not formulate again the mathematical models, but somehow you need to understood those to be able to solve the problem using the tools that we learned today. Okay. Well, let's first start from the overview. For today session, before you implement those mathematical models that you learn, well, these tools sometimes known as or in a different term, such as mathematical programming or mathematical optimizations. But basically, those terms, I can say that it's refer to the same thing, in which mostly we will use those terms to define an activity that where we want to solve problems that consists of an decisions that you need to optimize something. Okay, you need to select from some the best out of several options based on some criteria and based on several alternatives as well. So those are the terms that referred by the mathematical optimization, mathematical programmings. So when you learn the mathematical programmings or mathematical optimization, basically there will be at least 3 elements that you need to understood in able to implement those models using these techniques, those mathematical models. Okay, first, there is a necessary that you need to able to get the data. Okay, data means here it can be from the resources that you will utilize in your model. For example, like if it is decision related to producing some things or manufacturing some things, perhaps you need to know how many working hours are available or the throughput or of your machine. Those are data. And for this session, we simplified the input that categorized as deterministic values, in which means that the input will be known in advance so that we can modify the model in a more simplified way. Okay, and other than data, you need to also understood the variables, in which here variable means the decision that you want to make regarding to the optimization problem. Okay, variables will define the decisions that you are going to make for those optimization problems. Well, the variable itself represent the solutions. Okay, later on, when you solve the optimization problems, the variables will determine the solution of your the optimization problems that you want to solve. Okay, for example, if you want to make a scheduling for your resources, you want to schedule the human resource in your company. For example, you want to know, okay, you will work on what day, on which shift. So it means that the decision is regarding for each entity, for each person, for each human resource that you have, you will decide when and in which shift he or she need to go to the office, for example. So it will represent it in the variables. Well, there are several types of variables, for example, binary variables, integer variables that you already learned, of course, in the mathematical modeling that we discussed earlier. And constraints represent the equalities and inequalities in mathematical formulation, in which they define the scope of the optimization problems that you discuss in the models. And it's also can be used to define the specification and the rules of how the variables can be decided for your optimization models. Okay, so the constraints is often define the relationship between the variables and the data, the problem data. Well, those are three basic components, and another important one is the something called objective function. Objective function is the things that you want to achieve, that you want to optimize. How it can be measured, those are called objective function. For example, let's go back to the production decision that I mentioned earlier. Well, if you produce something, there is two type of objective that commonly considered during the production. Whether you want to maximize the profit from the product that you generate, okay, with a limitation of some machine capabilities, the human research capabilities and stuff. Or you want to minimize the total cost of the production operations. So those are the example of objective function. Okay, move on to the optimization tools and solver. So basically, when you're able to create an optimization models, like what we discussed in the last week. For example, you create a mathematical model for location decision, whether it's in terms of covering model or median model or center problems models. Those models cannot be solved directly without the help of tools, because sometimes you can calculate it manually because it's basically mathematics, right? Algebra and stuff, and you can use simplex procedure and algorithms, and you can calculate manually. But the problem is that most of the constraints, the variables, the interplay in between those factors will be too much for you to calculate manually. Okay, so most often we will need the help of computers. Okay, we will utilize computer software, and in which here those specific software that are used for solving mathematical models, especially mathematical optimization models, is called optimization tools. Or in those optimization tools, we will have something called solver. Okay, for short, they use the terminology of solver to define the tools that that implement those algorithms that you do manually, like simplex algorithm, branch and bound, branch and cut. It's implemented in a software called solver. Okay, and well, of course, the terminology of the optimization tools and solver would vary in the different field. Okay, but when you talk about optimization problems and then you talk about optimization tools and its solver, well, most often it will be referred to this type of software. Here are some personal selection, I can say, because there are many software like here listed in the, well, it's in Wikipedia, but somehow I think those list is quite relevant, so I put it here as a reference for you if you want to check later. But here are my personal selection that I personally have chance to either explore a little bit or sometimes even try and then able to use it for my research. Okay, so here is my personal selection. I categorize it into three type of optimization tools and solver. Okay, there are free tools and solver, and then there are proprietary. It means it's commercial, and normally you need to spend some money to buy those software to be able to fully utilize the feature. And the one that that provide academics version of it. So it means that for commercial use, you may need to pay some amount of money before you can use it. But for academics, somehow they provide full scale, full feature without need any extra cost. But you need to prove that you will use it for academic purpose, such as the things that the one of it we will try to utilize today. Okay, this is a discussion for later. Which one is better? Which one is more powerful? But I will not put that discussion in the class that we are discussing today. My aim for today is that I will try to introduce you to one of it. But later on, if you have a chance to explore other software, for example, today I will introduce you to AMPL, but I heard that Gurobi Cplex can be directly used in the programming language directly. For example, you familiar with Python, you can call the Cplex directly from the Python, and it can be it opened many opportunities. For example, you want to make applications and stuff. Those are things that you may want to consider, those type of features and ability. Or you want to or you want to explore more like free and open source software, such as the list of software that listed in CoinOR, or OR tools is actually supported by Google, so you may want to check it also. And Minizing, I heard this one gain more popularity lately, and if I'm not mistaken, at first it's developed by researchers and fellows from Australia in Melbourne. Okay, so those are the of course the proprietary will be very good for you when you are able to spend some money and get the fully feature of it. I mean, like, it's not gonna cheap, but it will be supported by a company, a well-defined support system that you can ask. But this list is it may have an update. For example, AIMMS lately mentioned that there is academic version about it, or I'm not sure. But this is just my personal knowledge, but the updates may be out there, so you may want to check. But our goals today, learn one, and then later on, if you are interested about it, you can explore more. Okay, now about the solver. Sorry, this somehow I mentioned also this one earlier. Solver is a software that accept the mathematical models that you develop in terms of optimization problems. So a mathematical model can be any, right? Can be like simulation, also can be defined as mathematical models. But solver here that we discuss is more specific to a solver for optimization problems that define in a form of mathematical model. So there are two main challenges that that the solver should able to address. First, whether it able to generate the feasible solution, because most often if it is easy to generate, we will not model it as a mathematical models. And uh, when it's complex, we start to use these tools, then it means that the feasibility of the solution will be rather not easy to find, and so those become the challenge of the solvers. And the other one is it's even more difficult, where you need to find the optimal solution of those optimization problems that you find that you define in the mathematical models. And a good solver, one of the criteria is it able to find a feasible solution rather fast, and most often it can find it. It needs to be able to find the solution until the optimality. But later on in the chapter, in the next 2 weeks, I think you will see that several problems is so difficult to find until optimality, so that you need to utilize different type of approach, not using the mathematical programming approach. Okay. Well, in the first week, I also explain or describe to you a little bit. There are several types of mathematical models. There is linear programming, non-linear programming, stochastics and stuff. Well, each of those type of models need to be addressed by how to say, you need to see the solver whether it's able to solve those type of problems. For example, if you say that it's a non-linear programming problem, so you need to see the capability of your solver, whether it can address the problems belong to linear programming. Okay. Oh, sorry, non-linear programming. Okay, so this definition is I take from Gurobi. Gurobi is one of the solver, one of the well-defined and famous solver, if I can say. And we will use this solver, but it can be called or it can be coded from AMPL. Okay, so we combine using AMPL as the mathematical programming language to describe the mathematical problems, mathematical model in a programming way, and then we call the Gurobi solver to solve it. Those are the things that we will learn today. Okay, before I start the demo, I will take several video from YouTube that I think it can provide you a little bit of initial understanding about this optimization tools and solver. But I will not record this video because it's from YouTube, and I will stop the recording first, then I will continue again later after we play the video. Okay, yeah, you can also see again all those video on the YouTube. I provide the link here. And it's time to start our own experience on the software. Okay, first of all, you can download the link that I provide to you. That one, let me try to open, sorry. Okay, here you go. Okay, if you open those links, it will direct you to my Dropbox folder. You can download it here, download. And after downloading it, you will get the file, a zip file that consists of all those AMPL AMPL the software that we are going to use. Okay, this is the zip file. You can see here it's a compressed zip folder, and you need to extract it first, either using WinZip or WinRAR or any archive software to extract the files. Okay, after you extract, it will show you this one, this folder. Well, basically it is similar with what you are seeing from the tutorials that the links mentioned previously. But here I only download several solver like Groby, Minos, and Express. Okay, to make the file is less than the normally if then the full package. Okay, but if you need more, just inform me later. I will tell you. I will give it to you again. But we will use the Groby file here. And regarding the example here, there is a lot of example you can try, but I prepare several specific example that is suitable for this class that we already discussed also earlier. So it will be let your learning curve is easier compared to use those mentioned in the books. Well, basically, AMPL also provide the books that you can download in their website, ampl.com, I guess. Okay, resources, AMPL book. Here you go. Okay, here you can download this. I think it's for free if you download here, chapter by chapter. Okay. And all those examples are described in this book. But we will not go there. It will take some time if you want to learn all of those examples. So I specifically generate several examples that might suitable for you. Okay, first, you may want to try to run the AMPL IDE and to see how it's run. Wait, it's in the, it's okay, here you go. After it's finished loading, it will up and load a application that shows like this. Yeah, like the explanation in the previous video, there are 3 parts. Here is the command prompt in the middle, and the left is the files that is available on your current working directory. So you need to make sure that you will put all the files in one folder, and you need to open those folder from here. Okay, if you are somehow ends up in different folder and then you try to run those models that you that is saved in the different folders, it would not work. Okay, so here I also provide to you here the examples of several models that we discussed earlier, like covering problems, maximum covering problems, and transportation problems. And I think I also give it to you the link to download all this sample. Yeah, here you go. You can download all of this. Okay. And again, it's the same way. Just click and I think download. Where is it? Why there is no download here? Yeah, because it's my Dropbox folder, I think you should be able to download it. Oh, perhaps. Yeah, here you go. Download. You download that one, extract in one folder, and then you put it again uh, uh, in one folder, and then you load it from here, the current working directory. Okay. Let's start from the example of the problems that we learned. The first problem that we learned earlier. Okay, here. Wait. Okay, this one is set covering problems. Okay, if you go back to uh, the PowerPoint that we have last week, you can see that we already discussed a set covering problems. Okay, and in set covering problems, let me remind you again what is the model looks like. Let me open the materials that we used last week. Okay, here you go. Yeah. Okay. Set covering problems look like this. Okay. Okay. So you will have input parameters in which it's the adjacent matrix to represent whether one facility is covered by another facility or not. One node is covered by a facility or not by represented using a binary variable Aij. And the cost of locating a facility is represented by F. And the decision variable is to locate or not to locate a facility Xj. And the objective function is total cost of allocating facilities. And of course, you want to cover all the demand or the demand nodes, at least by a facility here, based on this constraint. Aij multiplied by xj greater than equals to 1. It means that at least one facility will cover a demand nodes here. And I take this example. I'm using this example and then try to model the data here using AMPL. Well, in this example, actually they expanded like this, right? But we will use a general algebraic form to write it using this one so that we can have a nice separation between models and the data. Okay. For the examples, let me show you. It's here. Okay. It's implemented in these two files, cover.models. Okay. And covers the data. Okay. Well, the first example here is just to demo it to you how it can work and how to run it as displayed in the YouTube example that you saw earlier. Okay, here this model, well, it's basically look alike with the mathematical models that is shown here, right? For example, I and j, you will have set I and set j, okay? And the parameters or the input, you have aij, fj here. I set j, fj. What is this and what is this? I will explain it again later. And you have a binary variable xj here, x j in j. It's a binary, should not no need this one, just binary here. Okay, and the objective is to minimize z, minimize. Okay, this can be mentioned as a Z or objective or cost. It's just the naming, as long as it's not taken the reserved keyword like var, binary, sum, and so on. And it's a summation of J in J. It means like this, J, element J, represented by this one. And it's a sum of Fj multiplied by Xj, Fj here, multiplied by Xj here. You notice here that there is another type of bracket. For this one is curly bracket. This one is how do we call this one? This type of bracket. It has different meaning. Okay, later I will explain to you also. And the constraints in the previous YouTube video, they use s.t. It's a, they also mentioned that it's an abbreviation for subject to. Here I write it in the complete form. Subject to here, this one, the coverage. This is just a naming of the constraint. Cover, or you can use a subject or constraint one or anything. And for all here, for all I, element I here, we use the curly bracket for all I element I. And some J element J here, some J element J, J in J, Aij multiplied by Xj, Aij multiplied by Xj greater than equal. Okay, that's all the model. For the data here, basically data will populate all the set and constraint in the model. So whenever you define a set and define a constraint here, you need to populate those data in dat files. Okay, for example, you have here I and J. I put A, B, C, D, E, F. Where do I get this from? It's based on my problem, the problems that I'm going to solve, in which it's here. I have a set of nodes I, set of demand nodes I. It consists of A, B, C, D, E, F. Okay, it can be a string, or it can be an integer. So for a set, you can use those type of variables, type of naming in the set. And also because the set J is the same with the set I, so you will have A, B, C, D, E, F as well in the J. Okay, and F, okay, since the cost is uniform, it's all equal 1. So you have all set, parameter F, and you need to give colon equals. It's for the declaration of you giving a variables F index A is equal to 1, F index B equal to 1, and so on until F index F. F index F. So F here and F here capital is different because AMPL is a case sensitive. So when you have here small f and here capital F, it means different things. If also small a here and capital A here. Okay, this one represent the AIJ metric or the adjacent metric. A from A to A is 1 because if you open in the candidate, if you want to open a candidate A here, it will cover the demand nodes A here. And if you open a facility in A here, it will cover as well the demand node B here. Those are the covering problems data. Okay, to run this, you need to go to the middle part here, and you need to type the command for the AMPL. Because this is the first time we use the models, so we need to define first what model we are going to solve. model, and it should be the same name with the model that we are going to solve, covered mod. And don't forget to put the uh, uh, dot and comma here. And you need to also specify the data, that, yeah, like that. And you need to select the solver option, solver. Okay, in the video they use Cplex, but since we don't have Cplex here, and I think Gurobi is also as popular and as powerful as Cplex, so I guess we will use just Gurobi, since the problem is can be solved also using Gurobi. And the last command is just type solve, then you will get the objective value. It means that you only need two facility to cover all the demand nodes that in the problems. So you can display the variable x here. Here, the facility being selected is C and D. Okay, if we go back to the problem here, yeah, it's the same. Z equal to its facility C and facility D to cover all the demands. Okay, that is for the first demo here. Let me ask, anyone try this one already? Okay, that is the example that we use on how to use the AMPL software to solve the set covering problems. And I already provide you the files for this one. Okay, let's break down what is happening there. Okay, first we start from the basic knowledge that, or we can say it's simple rules that is implemented when you use AMPL for solving your optimization problems. The first is that, as you noticed earlier, the AMPL is a case-sensitive mathematical programming language. It means that when you have different parameters or variables name, it can, when you have the same letter, but one is capital, one is not, it's considered as a different variables in AMPL. Okay, and so you need to be careful about that. And then for the AMPL, for the data, for the parameters, it basically ignore white space. What does it means? For example, if you have one space or two space or three spaces to separate from, let's say, the param and the name of the parameter name of in your models or in your data, it's basically ignored. So it can consider as one white space. Okay, so it's ignore white space. It means that as many as spacing or tabbing that you use in your model or data, it's not relevant with the result of the models that you use. Okay, and okay, you need to write the model in a text file. Well, but the extension of dot mode or that is just to differentiate. Basically, any text file that you throw as a model or as data with different type of extension still work, as long as it's inside of it, it's follow the rules that we used earlier. Okay, dot mod and dot dat is just to differentiate which one is model, which one is data. It's for convenience of the user and the one that use your programs later. Okay, and when you type a command in in the middle part of the IDA or the AMPL and colon, the model will be solved after you type those letters solve. Okay, and the comments are denoted by number sign or pound sign, or nowadays we know it as hashtag sign. And all the statement after those sign were not being executed. It's just a comments to help the model to know what is written there. And every statement must end with a semicolon, dot, and then comma at the same time. Those are semicolons. And yeah, those are the basic knowledge. Some basic knowledge. They're the same. I think I copy the slides. Okay, now let's explore another variance of covering problems, which called the maximum covering location model. We also discussed this model earlier in our last week session. So basically, these models allow us to not cover all the demands in the networks, but you need to maximize the demand coverage by selecting the facility being used or being open, but it also limited by how many the number of the facility that can be utilized. Okay, and we need the input as shown here. We need the information about the demand at each node, the number of facility being located, P, and this one is still the same, adjacent matrix. And we need to utilize one more variables other than xj that we already utilized earlier. We need to introduce zi, in which it means that to represent or to denote whether customer I is being covered if you open facility J. For example, in the previous set covering models, is like if you open facility in A, you will cover A, B, and C. So Zi will be equal 1 for ZA, ZB, and ZC. That one. That's what it means. And we want to maximize sum of all demands being covered. The demands represented by HI, which I mentioned earlier in the parameters. And the decision whether it's covered or not is represented by Zi. Okay, HI multiplied by Zi is mean that maximum demand being covered. Okay, and I think I already mentioned this one, Zi less than equal AI JXJ. It's just to make the value whether if you assign to facility J, so the facility Z will be open. Oh, sorry, we will denote the demand at node I will be covered, something like that. This represented by this constraint number 2. And last constraint is to make sure that the amount of facility being utilized or being open is not more than the number of facility that can be located. It is the constraint. For example, you can only open 5 facility or 2 facility or 1 facility, so the number of P will be equal 1 or 2 or 5. Okay, and this one is an example that we used previously on how to solve this one. Okay, and we expand the models such a way that each constraint is expanded one by one like this. to represent whether node A is being covered, node B is being covered, node C, node D, node E. Okay, this is the expansion of the constraint number 2 that we mentioned earlier. And for constraint related facility is here on the right side. And then for the data is all here, the data AIJ matrix and the HI, the demand of each node I. Okay. Well, you can use Excel to solve this one, but you can also use AMPL. So for AMPL here, I try to give you a simple expansion. Previously, we already make the more complex one. Okay, this one is the simple one, where you, after you expand it, you write as is expanded like this. For example, you need to have how many variable here? X and Z. XA, XB, XC, XD, XE, XF, and then ZA until ZF. Okay. And then it is, okay, for now, we will allow the decision variable to be continuous. Okay, here, XA greater than equal 0, X or less than equal 1. This is just an example. Okay. But actually it should be binary, right? Later we will change it to binary. And for this one, the objective function minimize OBG 10 ZA X CB 22 ZC, we translate it into like this. Okay. Maybe I can utilize some pen tool. Okay. Yeah. Yeah. Okay. Wait. Okay. So this one is represented here. Okay. And sorry, not good. Let me set again the pen later. Okay, minimize objective here is represented here in yeah, this one. And node covered for A is XA plus XB plus XD greater than ZA. It's this one. XA plus XB plus XD ZA. So you can see here we have the objective name is OBG here, OBG. It's just a naming. You can change this one to another name, for example, objective value or the small z, or here, yeah, it's depend on what you need. Here we have the name for the constraint of also node A covered, so I translated here, subject to node A covered. This also a naming only. And colon XA plus XB plus XD greater than ZA. Okay, don't forget the semicolon here. Okay, all here you need to translate, and here, yeah. And here for the P, I set it's equal to 1, so I just write it less than equals to 1. And for the integrality, for now, we simplified, we will not consider this first. Later, we will, how to add this binary consideration here. I will mention it later. Okay. Then, okay, here just another explanation that let's show some characteristics in the modeling. First, you notice that every line is, or statement, it will end with semicolon, and the decision variable are declared using var. So when you have decision variables, it is represented by var here, meaning variables, okay? And the objective function is declared whether it's maximize or minimize, and then There is the name of the objective variables and then the how to calculate the objective function. And the constraint is represent or declared using subject to here. Okay, subject to. And each constraint will get a name, node A, node B, node C, node D, node E, and number to locate. Okay. Okay. Yeah. Yeah. Then we can start solving this model. So we will have here maximum coverage simple.mod, and then we try the in a moment we will try this type maximum cover simple. I create new file for this one, the simple version of the maximum coverage problems, and we will see the result look like this 84. It should be the same with the examples that we shown previously, and this one showing the value of the objective function here 84. It is achieved by 7 simplex iterations, so that you're using simplex. And if you want to see the result, you can use a command display here. Display which variable you want to display. Okay, okay, let's try this one. I already prepared for you as well. We go back to this AMPL IDE, the console. Here, let me close this one first. Close this one first. Here, okay. I also provide to you the maximum covering symbol here. Okay, this one, the one that we just discussed earlier. Okay, and wait. Yeah, this one is already converted to binary. So before this, we use greater than 0, less than 1, something like this. This is not correct, but this is just for the sake of example, that you can use a variable, that you can define a variables as shown here in the screen. It doesn't have to always to be binary. So this is one example how to declare a variables that is a continuous variable greater than equal to 0, less than equal to 1. Okay, and to solve this one, you need to type models max cover simple.mod, and then wait, objective, oh sorry, because we already define the model here, so you need to reset the model first. Okay, and then models max cover simple.mod, and then you don't need to mention the solver again because it's by default will be using the last solver, and then you just need to solve it. Okay, see, you get the result. And then if you want to know which variables are being covered, which nodes are being covered, you see from the X, if you want to see which facility is being open, you see from the X variables, XE, XF. Wait, display, X, display, yeah, misspelled. Okay, so we will open facility C in which node are being covered by facility C, shown by Z. Yeah, C will cover C itself, E and F. And if you see the demand here, C, E, F, okay, 22 plus 7, 29 plus 55 equal 84. Yeah, Those are the maximum demand coverage if you allowed only to use one facility. What if you want to use two facilities? So you need to change this one, become two. Okay. And then again, reset. And again, oh, you can press up and down arrow to show again the command that you already typed earlier, so you don't have to type several times. Model command maximum, you already save it, you already reset it, and then you load it again, and so forget. Now we have objective solution 121 because we are using two facilities, XB and XC, and we see that, okay, here, all demand is already covered. Okay, so it means that even though you increase more the facility that being open, the objective function will be the same 121 because all the demands already being covered. Okay, those are the demo about this. And let's go back to the slide here. Okay, yeah. If you want to make it binary, okay, previously the result is already binary, right? So it doesn't matter if you, for now, it doesn't matter for your result if you even you use the left here and the right here, but it is not correct since your variables in the model should be binary. So you should mention it like this. So you should write it like this instead of the one on the left here. Okay, but for this example, there is no, it will not difference because the objective value of the previous result is already binary. So for this one, they have no effect. But again, the correct way to define binary variables should be on the right side here. Okay. And after you solve it again, okay. Yeah, up until here, anyone want to raise question? Because this one is the simple version of the algebraic models. As you can notice here, we are not using the data file. Why? Because all the data already embedded in the models. But that's not a good practice. The best practice will be, again, as mentioned earlier, to separate the model and the data file. Okay. Up until here, do you have any question regarding to this example?
Yes, sir.
Yeah, please.
Sir, can we go back to the AMPL?
Yeah.
I just have a question because I was trying to, yeah.
AMPL. Okay.
Sir, how on the second line, how do we include the max cover simple that the model, sir? On the second line of the yeah.
This one.
Yes. How do we include the max cover simple? Because I missed that, sir.
Okay. First of all, okay, let me clear the screen again first. First of all, if you open the file, it will be look like this. And this one, the current directory folder will be normally on, I'm not sure, C something, maybe here, like this. Okay. So you need to first find the directory where you save your AMPL file and folder models. Okay, for example, I put it here in the, sorry, my mouse doesn't respond. Okay, here. Here, I put my example file in here. So you need to find this folder first, in which I already give you the file. All of these files already populated in the link that I give you previously. Then you need to open it first to see whether the file is correct or not. For example,
the max cover simple.
Yeah, here you go. Then you can use this model here. Model max cover simple.mod. sorry, you need to reset it first because we already loaded previously. Reset, and then model max cover simple dot mod. Okay, okay, and it works.
Yeah, when I type it for the model max cover simple dot mod, then
Yes.
there's a can't find the file.
Yeah, it's look like this. If you are not in the correct folder, like I mentioned here, for example, here, there is no max cover simple model here. Then let's say I already opened this one, right? But
Yes.
here the folder is not in the correct folder. So if I reset model max cover simple mod, even though it's shown here, but it's not in the correct folder, it will raise some error.
Oh,
Okay.
okay, sir. Thank you.
Okay, good. Yeah, there are several problems you will find only after you try. That's why I think it's really good to try. So later on, if you already have chance, I really recommend it. You need to try all of these examples. Okay. Okay, let me go back here, then reset. Here you go. No error. Option solver Rovi solve. Yeah.
So it means, sir, that the directory should only be showing that folder, specific folder, right?
Exactly. So you need to
Okay.
put it in the current directory to the correct folder.
Okay, sir. Okay.
Yeah.
Thank you, sir. Thank you.
Okay. Anyone else have questions? If not, we will move to a more best practice approach for modeling this one. Okay, because as you can see here, we don't have the separation for the models and the data. All the data is embedded here in the model. And for example, if you want to change the demand, you need to change all this file, right? Then it's not, and then if you want to change the adjacent matrix, you need to add more constraint here. Okay, so next we will learn on how to use a more general or algebraic approach. It means that our model so far working okay. It means like it works. It can give you a solution as you want, as designed. Okay, but somehow, let's say if you have different adjacent metrics, for example, the coverage previously is 11. Let's say if you have 15, what should you do? This will change, right? This will change and this will change. It means that all of your model will change, and it's not robust. It's not efficient. So instead of doing that, we can come back to these models and create the AMPL models as shown as the model here. So we follow this approach instead of the one that's already being expanded here. Okay. Okay, if we come back here, we will find the models can be represented like this. We have, okay, let me, yeah, this one basically mention again the one that my concern. It works, but the previous format, the format that expanded there, it will be big pain if you involve more variables. You need to change the data, and somehow all the model will be changed. Okay. And the solution that we use here, the algebraic approach, means we will represent and using sets to index the parameters. So previously we don't have sets. Okay, now we will use set. What is set? Set is like how many a set is several index categorized into one groups. It's a set. For example, set of demand nodes. So several index of demand nodes collected together as one group called set J. Okay. Wait, I forget what is J here. J. No. Demand nodes is I, and then facility nodes is J. Okay. Well, let's create a new models or new files called maxcover.mod. Okay, it's displayed here on the right. We will create it like this. And if you notice that parameters, variables, all indexed by set, and set for each parameter will be written as a curly braces. Okay, here is the set I and j. For param f, you need, if you are using a set here, you will use a curly braces. It's represent that inside here there is a set. So f will have a component as many as set j being defined. For example, if set j have A, B, C, D, E, so F will have FA, FB, FC, FD, FE. Okay, that how the relationship being defined. Okay, next, for index in objective and constraint, you use square brackets to index the parameters and variables. Okay, curly braces is for set, index using square brackets. For example, here params you use curly braces, curly, all represent the sets. Variables you use curly braces. Here it's a little bit different, j in j. So the index you will give the name j for x. For here, you will use the name I for the z. Okay, I in I. It's a binary. Okay, and here for objective and constraint, this is the set, right? Sum I in I, so set I. But for the index here, hi. So you have the first set, the first component in set I. Let's say I equals to 1, so h1 or ha, hb. The index is written in square brackets here, square brackets. Okay, this one represents set, this one represents index. And then for constraint, for all I in I, okay, this one is set, this one is a index zi. Okay, that's the things that you need to notice. And well, the hashtag, of course, still the same meaning. It's mean comment. It can be ignored. And the summation index also indicated with curly braces here. Summation index here, it's the same with sets here, set using curly braces. Okay. And you see, there is no number here. Okay, so this will contain only the models. All the data will be provided in a separate way. And then we need to go and create the .dat file. Okay, and this separation of models and data is one of the best practice, and it's a core to AMPL philosophy. Okay. Here you can see that how we define the data data will populate all the set here, set and parameter. You have set I, set j, parameter f, parameter h, parameter a, parameter p. In the data, you will populate that with a data that you will use. Set I consists of A, B, C, D, E, F. Set J consists of A, B, C, D, E, F. Parameter F consists of A, B, C, D, E, F. A equal to 1, B equal to 1. It means that the fixed cost is 1, 1, 1, 1. Okay. And it's basically the same with the set. Now we are not only each line, but each command. Okay. Each command means set ij until this one is one command to define set I. But for here, one command is param f colon equals a1 b1. It's to define one command to define parameter f, this one. Even though they put enter here, it's basically the same with you write it in line to the right here. Okay, just for the simplification, we write it as follows. Okay, set and element can be a string here. Set can be a string, can be a number as well. And the declaration dot colon equals mean set I have the value of this one. It's the declaration. It's also this one. Parameter have the value of fa will be equal to 1, fb will be equal to 1, something like that. And also even with for parameter with two index, a ij, right? A from A to A from A to B, from A to C, and so on. Here, two-dimensional. Okay. And yeah, previously we have P, parameter P on the right-hand side as the parameters. So we move also to the data. We define it as a parameters. And now we can solve the model. Solve the revised model, max cover.mod data. Now here we have data. Previously we used only model, right? Now we use the data also to provide. If you have another data, the model name is still the same. You use the different data. Data max cover 2, max cover 3, something like that. And for the display, you don't need to expand the writing like XA, XB, X index A, X index B, X index C, until X index F, but you need to only mention the display X, and then it will automatically enumerate the result for you here. And also display Z the same way here. Well, okay, after this, I will discuss a little bit more detail, but let's try this one first. Okay, here you go. I open the max cover mode here, and then max cover data here. And we try the reset model. Max cover mod, wait, subject to cover I in I. Here, there is error here. We don't have this semicolon. Okay. Later, I will tell you how to debug the model. There are several common mistakes that often appear like this. Okay, this one, save, reset again, model max cover dot mod data. Okay, we have data now. It's separate with the model max cover dot dat. Option solver Robbie. Here you go. It's the same with the previous one. Yeah, because this is the same model. Instead, this one is more compact and it's separate from the data and the models. And when you want to display the result, you just need to display X and display Z. Yeah, here you go. You get the same result basically. Okay. For this one, because you already separate the data in the model, you don't need to do anything about the model if you want to have another data. For example, oh, I want to change the adjacent matrix. For example, let's say the coverage is bigger. So I need to provide new data. Let's say I made a new file, max cover 2 dot data. Okay. Okay. Here, all the same, but I will change. If I open A, I will also cover, let's say, D. And then if I open C, I will also open, let's say, sorry, D, A, okay, C, let's say A as well. Okay. What will happen? Let's check it out. Reset. Model max cover dot mod. Wait. You can find model. Oh, sorry, twice. Sorry. Just reset again. Models max cover dot mod data max cover. We use the second data now. Dot 2 dot that solve. Okay. Yeah, it's still the same. Why? X. Okay. Yeah, because we only open one nodes, right? There is no differences. Okay, let's make some differences that let's say opening C, oh sorry, opening A will let you cover all the nodes perhaps. Okay, let's try again. Reset. Let's see here. Okay, reset. Model max cover 2 max cover dot mod data max cover 2 dot that solve. Okay, see display, they will open which one? A, because A cover, you open A will cover all the node demand nodes. So now the decision is changing. Yeah, that's how you can experiment on different data without changing anything in the model. Okay, separation of data and model is important. Okay, now I will explain a little bit more detail. Okay, first about the what is it? For all constraint here. How do we address for all constraint in the model? As you can see here, the it's a constraint you will need to write subject to, and then here is the name of the constraint, and then you need to write the for all here after the name of the constraint. For all I element I in I. If you have two I in I and J in J, so I in I comma J in J here, or before the colon here. So for all constraint, you need to write it this way. That's one explanation. And then another thing, yeah, is yeah, the summation is already being explained. For all already being explained, the binary is also, so it's all good. And we already tried as well. Okay, now we discuss about what can go wrong when you do the modeling. First, we already see earlier when I forgot Jeremy or Joshua asked, we need to make sure that we put the current directory folders as same as the one that we are going to experiment on the command prompt. It means that if you want to work on max cover file, so you need to put the current directory folder where you can see the max cover model file in this current directory. If not, an error will be raised here when you try to call those files. It will not find the file, something like that. Another thing is, as you can see here, sometimes you forgot to define the subscript, but somehow you utilize it. For example, it's often called dangling subscripts. Okay, dangling subscripts mean that you use the subscript in the either the objective function in the constraint, but you forgot that you are not yet defined it. Okay, for example, here, let's say here, if I erase this one, it doesn't show an error here directly, but somehow AMPL will help you to mention that hi multiplied by zi. So reset model max cover dot mod. It will mention to you, hey, you use index I here, but index I is not defined yet. They will not tell you you need to put some. No, they don't understand about that. The model, the machine doesn't know, but they can tell you that you use the index I here, but I is not defined. Now it depends on you. How do you use this one? So for our example, our case, we want to sum it. So we have I here, sum I in I. Okay. Okay. Those are one example of an error that might happen. Another example of an error. Okay, the dangling variables or the dangling index, sorry, dangling subscripts can also happen in the constraint. For example, here, let's say I forgot to use here the for all constraint. Okay, then I try to use the model, sorry, reset model max cover dot mod. Here you go. The same way, you will find there is an error here in line 20 offset 2252. How do we find this one? Basically here they will mention to you, or you can click this one, line 20, click. It will let you go to that one. This is line, what line is this one? Okay, here, sorry. Okay, here on the right corner below, this is line 19, offset 248, 19 248. If you go here, the line is increasing 20, offset 250. So 250, 252, here you go. 252 is around here. Zi is not defined. They will not tell you what to do, but they will direct you to where it has, they find the error. Okay. For our case, we need to put here, the one that we just take out earlier. Okay, another thing is sometimes we use the same index name for some and for all constraint. What it means? It means like this. This one, I in I, right? This using index I. Here, you use J in J. This is correct. But sometimes we forgot that I here, and then we use the same number here, I again. Or you use J here, and then here you use J again. That's a mistake. You cannot do that here. They will inform you there is an error in the models, like this. Okay, it's the same error, but somehow it has different way to solve it, because the same error here, I is not defined. You use I here, but you don't know define I previously. So now you, based on your knowledge, you need to know which one should be I. In our case, it's here for all I, right? Okay. Okay. That's another type of error that's often met by students. Another is misspelling. Sometimes you spell it not correctly, like here, should be Z, you write Z and Z, it's misspelling, there will be an error. And then another thing is data. The data is missing. So for missing data, you will not find it until you run the problem. For example, here, let's say we take out the P here, okay? It will not raise any error. Here, model, data, max, cover dot that. It will not raise any error until you solve it, right? When you solve it, they try to find P value, and P value, they don't find value for P because we just delete it, okay? Okay, those are things. And forgot to put semicolon. That's also a problem that will raise error. And okay, that's all about the error. And let's try another example. Well, for this one, how to formulate p-center models. Okay, for this one, I will just go short explanation. We will have the data like this, and we will create somehow model it as follows. We separate the models and the data as like this, and then you will have to try to run the problems like this one. I already create the example for you. Here we go. Yeah, this one. And the same way, we set model cover mod data cover that function solver will be solved. Okay, display x. Okay, so this is a covering problem. So you want to put a facility where the furthest coverage is minimum. Okay, those are the problem. You can go back again for to see the explanation of the models. And again, for p medians, okay, I think I will let this one as a practice for you, as an assignment. Please try to solve this one. So you have this model, and then you need to find the optimal objective value for the p median models, in which you consider p equal 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Sorry, 6. Yeah. So which p will you select and why? And this is the data. Okay, I think that's all for today's lecture. I hope this can be a good introduction for you. I'm sorry that I could not give you both approach today, because I think that let's focus one by one so that your learning curve will be easier for learning this type of new tools. Up until this, is there any question? Okay. Let's stop the recording.